I think when most of us hear quantum computing, we still picture something, 30 years away. Scientists in lab coats. But here's the uncomfortable truth. That timeline. It's completely obsolete. The quantum age is arriving, and it's coming much, much faster than almost anyone in the professional world realizes. And what's really striking is that the vast majority of tech-savvy professionals, the people who should be ready, they have absolutely no idea how to prepare.
Right. They're just sort of waiting for a date on the calendar.
Exactly. But the people who figure out the roadmap right now, in this early window, are going to gain an absolutely massive career-defining advantage over everyone else. This isn't theoretical anymore. Okay, let's unpack this and figure out how to bridge that gap.
That's the mission today, to give you a complete, actionable roadmap for becoming quantum ready. And we're not talking about a conceptual overview. We're focused on the applied skills you need to actually use and build with this tech in the next, say, 6 to 12 months.
And the most important thing to say up front is you don't need a PhD in physics.
Absolutely not. You don't need years of advanced calculus either. You just need a willingness to learn and, well, the structured path that we've laid out.
So let's start with the so what? I mean, why the urgency? Why does this matter right now in 2025?
Because the impact timeline is sitting squarely in the next 3 to 5 years.
And the big companies, they're not waiting. IBM, Google, Microsoft, Amazon, they're already investing billions.
Billions. And they're building the cloud platforms and the hardware.
But what they're desperately short of are people. People who understand how to connect their business problems to this new capability.
What's fascinating here is that this massive investment means the quantum skills gap isn't really a problem.
No, it's an opportunity.
It's one of the biggest professional opportunities we've seen in a decade. Just consider a couple of examples. Let's start with pharmaceuticals. Drug discovery is all about simulating how molecules interact.
Right, which is famously difficult for classical computers.
Impossible, really. The complexity scales exponentially. But quantum computers, they can handle these interactions at the foundational level. They could potentially cut drug development time from a grueling 10 years down to 10 months.
I mean, 10 years to 10 months, that's not an optimization.
No, it's a revolution.
And what about in finance?
Same principle. A classical computer trying to optimize a massive investment portfolio, it just hits a complexity wall. The time it takes to find the absolute best solution explodes. Quantum algorithms, for certain optimization problems, they offer a quadratic speedup.
Which means they can find solutions that are just unreachable today.
Exactly, giving firms a huge, almost insurmountable edge in things like risk assessment or fraud detection.
And that speed up, it's not just theoretical. When you look at global logistics, think of operations like FedEx or UPS. Optimizing their delivery routes with these new algorithms could save billions of dollars.
Billions a year. And that efficiency translates directly into massive carbon emission reductions, too.
So it's not just about speed. It's about solving problems that were, until now, completely unsolvable.
And all of this urgency is compounded by cybersecurity.
The encryption problem.
Right. A powerful enough quantum computer, the kind we expect to see in the next few years, could break a lot of our current public key encryption. So we have this twin problem. You need to defend against quantum computers by developing new encryption, but you also need to use quantum tech for things like secure key distribution. It's a real race against time.
Okay, so given the urgency and this huge range of applications, the big question is, where should you start? Do you really need to quit your job and go get a physics degree, or is there a shortcut?
There is absolutely a shortcut. But before you even look at a roadmap, you have to figure out your target. And there are 3 distinct levels of quantum literacy.
Level 1 you call quantum awareness. What's that?
This is for executives, entrepreneurs, product managers. Your goal isn't to code.
Right, it's
Exactly. It's about understanding the timeline, the business implications, the risk, the reward. It's being able to confidently lead a strategic conversation about where this is all going for your industry. Then there's level 2, which is quantum application. This is the sweet spot.
This is where most people listening should be aiming.
Yes. Developers, data scientists, researchers. The goal here is capability. Can you use a quantum platform to solve a real problem? Can you write a basic circuit? Can you implement an algorithm?
So you're valuable immediately. You're applying the tech without getting lost in the deep theory.
Precisely.
And finally, there's level 3.
Quantum innovation. This is the deep end. This is inventing new algorithms, designing new hardware.
So this is where you do need the PhD.
This is where you need the PhD,
Yeah.
yes. It's a huge investment. So for almost everyone listening who wants a strategic career advantage in the next year, level 2 application, that's your bullseye.
Okay, we have our target. Let's talk execution. And the best part about this whole journey is that the path to level 2 is built on almost entirely free, world-class open source resources.
That's right.
We've broken it down into 4 sequential steps to get you from absolute beginner to application ready in about 6 months.
So let's start with step 1, build your foundation. This should take you about 2 to 4 weeks.
And what's in that foundation?
3 concurrent pieces, and none of them are super advanced. First, you need basic programming skills, specifically Python. All the quantum frameworks are Python-based.
So if you're rusty, use something like Codecademy to get up to speed.
Exactly. Second, fundamental linear algebra.
Which sounds intimidating.
It does, but it's not. You just need to understand vectors, matrices, and matrix multiplication. That's because quantum states are vectors, and the operations you do on them are matrices.
Khan Academy is great for this,
Yeah,
right?
perfect for it. Just focus on understanding what these things represent, not memorizing formulas. And third, basic probability and statistics. Quantum computing is inherently probabilistic. You're just measuring likelihoods. So you can tackle all 3 of those at once in your first month.
Okay, once that base is set, we move to step 2. Learn quantum computing concepts. This is where you spend about 4 to 6 weeks building that intuition.
Right.
You start with the core ideas. What a qubit actually is.
Yeah.
How it's different from a classical bit. Then you get into superposition, entanglement, and most importantly, you learn to build simple quantum circuits visually.
And the key resource here is the free IBM Quantum Learning Platform.
It's designed for professionals, not physicists. And the amazing part is that from day 1, you're running your circuits on actual working quantum hardware in the cloud.
Not just a simulator.
Not just a simulator. You supplement that with the open source Qiskit textbook where the code examples run right in your browser. It's that instant application that really builds the muscle memory.
Which leads you straight into step 3. Master a quantum framework. Plan for 6 to 8 weeks here.
And the advice is to pick one and go deep.
You have to. We strongly recommend starting with Qiskit. The community is massive, the documentation is excellent, and you get that access to IBM's hardware.
But there are other options depending on your goals.
For sure. If you're in the Google ecosystem, you'd look at Cirq. If your focus is quantum machine learning, PennyLane is crucial because it integrates right into things like PyTorch and TensorFlow.
And mastering a framework means you have to apply it. You have to implement the famous algorithms.
Don't just copy the code, you have to understand why they work. For instance, start with the Deutsch-Schulze algorithm. It was the first one to prove a quantum computer could beat a classical one.
Then maybe Grover's algorithm.
Then Grover's search algorithm, which gives you that quadratic speed up for searching databases. And then you get into things like QAOA,
Which stands for
the quantum approximate optimization algorithm. This one is essential for solving massive optimization problems, the kind you see in supply chain logistics, network design, and complex scheduling. These are the algorithms that directly translate into business value.
Which brings us to the final, and maybe the most valuable, stage. Step 4. Specialize in your domain. Here's where it gets really interesting. Your unique value isn't just knowing quantum stuff.
No, not at all.
It's combining that new quantum knowledge with the deep domain expertise you already have.
That's the bridge. Most quantum researchers don't know the specifics of your industry, and most experts in your industry don't know quantum. You become that highly valuable bridge.
So if you're a financial risk manager, you focus on quantum optimization for portfolio rebalancing.
Exactly. If you're a data scientist, you focus on PennyLane for quantum neural networks.
If you work in defense, you specialize in post-quantum cryptography.
That intersection is the key. That's what unlocks the massive professional opportunity.
Okay, so let's talk about the support system. You're doing all this with a wealth of free resources.
We've curated the essentials so you don't get lost.
For learning platforms, you said start with IBM Quantum Learning, then maybe Microsoft Quantum Q Cadets, and Quantum Country for spaced repetition.
Right, and for deep practical experience, the documentation for Qiskit, PennyLane, and Cirq are your go-to references. But the key is, don't learn in a vacuum.
Join the community.
Join the community. The Qiskit Slack is enormous and incredibly welcoming. The quantum computing subreddit is great, and the quantum computing stack exchange is where you'll find answers to the really tricky questions.
But theory is only half the battle. To really get to level 2, You have to build things.
You have to. Don't just follow tutorials. Build something original, even if it's small.
Like a quantum random number generator.
Perfect. Or a simple quantum game. Put it on GitHub. And take advantage of the ability to use real quantum hardware for free.
Right. IBM, Amazon, and Microsoft all have free tiers.
Use them. Experiment. Break things. That is the absolute best way to learn.
So pulling all four of those steps together, what is a realistic timeline for a professional to go from zero to quantum application readiness?
I'd say 6 to 12 months of focused, consistent learning. Month 1 to 2 is that foundation building. You're learning Python, some basic math, and you're running your very first circuits on real hardware.
Month 3 to 4 is algorithm implementation. So you're writing circuits on your own, you understand Grover's algorithm, you're applying optimization.
Then month 5 to 6 is practical application. You're building your own small projects for your domain, and you're starting to get active in the community.
And month 6 to 12 is specialization. You're deep in your chosen area, maybe contributing to open source, maybe even writing about it.
Yeah, less than a year from beginner to quantum ready is completely achievable.
Okay, to save people time, let's talk about the biggest mistakes people make when they start this journey.
Mistake number 1, and it's a big one, is thinking you need to master quantum mechanics first.
You don't need to derive Schrodinger's equation.
You do not. That is level 3 thinking. Start with circuits, start with algorithms, and build the physics intuition backward from the application.
Mistake number 2.
Learning everything at once. Pick one framework, like Qiskit, and go deep before you go wide. Master one thing first. Vertical depth before horizontal breadth.
And mistake number 3, only doing tutorials.
Yes, tutorials are training wheels. You have to take them off, build things, break things, and figure out how to fix them yourself. That's how you build real competence.
And the final mistake is just waiting. Waiting for the perfect time, waiting for the tech to mature.
The golden window of opportunity is right now. This 2025, 2026 timeframe is it.
The ultimate implication here seems to be that quantum computing is going to create massive winners and massive losers.
It will, and the winners will be the people who strategically position themselves early at that rare intersection of quantum literacy and deep domain knowledge.
So what does this all mean for you right now listening to this? Let's give you a concrete 7-day action plan to get started immediately.
Okay, day 1. Create a free IBM Quantum account and run that first tutorial. Run your first circuit on real hardware. Proof of concept. Done.
Day 2. If Python is new for you, start a course. If you know it already, review basic linear algebra, just vectors and matrices on Khan Academy.
Day 3. Read the first chapter of the Qiskit book and work through the code examples right there in your browser. Get hands-on with superposition.
Day 4. Join the Qiskit Slack community. You don't even have to ask a question. Just browse the threads for 20 minutes. Get a feel for the ecosystem.
Day 5. Watch something visual. The 3 Blue 1 Brown videos on quantum computing are fantastic for building that intuition.
Day 6. Implement your first simple quantum algorithm from scratch. Even if it's just the basic hello world circuit, break it and then debug it.
And day 7. Share what you learned. A quick post on LinkedIn about the difference between a qubit and a classical bit. Teaching reinforces learning and starts building your presence in the field.
So the roadmap is laid out. The resources are free. The barriers to entry have, well, they've never been lower. The question is not whether quantum computing will transform your industry. It absolutely will. The only real question left is, are you going to be one of the people who is ready to lead that transformation? Or will you be one of the people who watches it happen, wishing you had simply committed to that first step this week? That is a choice only you can make.